Hello, I wanted to do a quick rundown of section 2.3, how to solve nonlinear inequalities. So basically, if we have a function that looks like this, all the parts of the graph that are above the x-axis are regions where we say f of x is greater than 0. And the parts that are below the x-axis are the parts where we say f of x is less than 0. So that's what we have to find, is the parts of the function which are positive and which are negative. So the way in which we are going to do it is this. In order to solve this, first I need to bring the 1 to the left side. So that's going to be x squared minus 8x plus 15 less than or equal to 0. Now, when I factor this, it'll be x minus 5, x minus 3. So basically, the reason why I do this is I want to find the zeros here. So x equals 5, x equals 3. I put those on a number line. And now what I want to do is, now that I've separated this into 3 regions, I want to plug numbers from each region into this and see if those values are going to give me positive values or negative answers. So suppose from this region I pick 0, and I'm going to plug it into these. I get 0 minus 5, 0 minus 3. Now from here, 0 minus 5, I get a negative number. From here, I get another negative number. The value itself isn't really important, it's the sign. Negative times negative makes positive, so here I get a positive number. From the region between 3 and 5, I can pick 4. And again, I plug it into these parentheses. 4 minus 5, 4 minus 3. From the first parenthesis, I get a negative, then a positive. Negative times positive makes negative. And then, so that's negative. Then from the last part, I can pick any number like 6. Plug it into the same parentheses, 6 minus 5, 6 minus 3 equals a positive number, a positive number. Positive times positive makes positive, so I get positive here. So it's important to know where to plug these numbers in. You can plug it into any form of the equation which compares it to 0. Okay, so either this one where it's less than or equal to 0, or this one. It's easier to do it in the factored form because the computation is just easier. That's the reason why I do it that way. We can't plug it into this because this is comparing it to 1, and that doesn't give us the correct information. Okay, so what we want now is the regions where the function is less than or equal to 0. So less than or equal to 0 or less than 0, these are our negative regions. Greater than or equal to 0 or greater than 0, these are our positive regions. So here I want the negative regions, which is this. Okay, and the way I can write that in set notation form is all the numbers from 3 to 5. So 3 less than or equal to x, less than or equal to 5. Okay. Let's do this one. And here, in order to make the math easier, I actually change this to 8. So I'm going to bring everything to the same side again. And that's going to be x cubed minus 3x squared minus 8x plus 24 greater than 0. This is a cubic with 4 terms. I can factor it by grouping. So I split it down the middle. From the left side, I can factor out an x squared and get x minus 3 minus 8 x minus 3 greater than 0. I have a common term of x minus 3. I can write it off to the side here one time. And then I collect what I haven't used, x squared minus 8. Okay, now Again, I need to find what makes these 0. So from here, I get that x equals 3. Now this one, x squared minus 8 equals 0. X squared equals 8. Take a square root. X is plus or minus root 2. So now I have all of those numbers that I can put on my number line. Root 2 is less than 3. It's 1.4. So the order it's going to be in is negative root 2, positive root 2, and then 3. Okay. So again, we're going to pick numbers here, and we're going to plug them into this. Okay, so let's say I pick from this region negative 10. In this parenthesis, negative 10 minus 3 is a negative value. Here, positive 100 minus 8, that's positive, so that gives me negative. Now, I can keep going and plug numbers. In fact, let's do one more. Here we get the 0. That's my favorite one to do because it's easiest with the computation. 0 minus 3 gives me a negative. 0 minus 8 gives me another negative. That gives me positive. Okay, now we could use a little shortcut here. If we look at where each of these came from, so the root 2 came from this parenthesis. Now, the exponent to this parenthesis is a 1 here. That's an odd number. It means at this value, the sign has to alternate. So if it's a plus here, I must get a minus there. Now let's go to the 3. Where did the 3 come from? The 3 came from this parenthesis. This parenthesis itself also has an exponent of 1. That means at the 3, the sign will alternate again, so I'll get a positive value there. Okay. You could also plug numbers in and you will get the same. Okay, so here we want the values which make this function greater than 0, so positive. That means I want all of the positive regions. That's here and here. Now in the first region, this region is bound between negative root 2 and positive root 2. So the way I do it is negative root 2 less than x less than positive root 2. So if a region is bound between two numbers, those two numbers go on the either end of this, and in the middle I always have less than x less than. Now on top we had less than or equal to because the problem itself had an equal to. This one does not, so we just do an open inequality. This region here is open-ended, and if you look at this, these are all the numbers greater than 3. So I just say, or x is greater than 3. And that's how I could describe the regions there. Okay, let's take a look at this one. This is an exception to the rule. Now if you can, so the goal was always to factor or to solve and get values for us to put on the number line. So here, this one actually can't be factored. And if you try to do the quadratic formula, you get an imaginary value, which doesn't help you. So you're stuck. So what goes on the number line then? Well, if we look at the function a little bit more closely, we could see that there's a lot that we could figure out just by looking at it. So let's just put a 0 here just to have some reference. If you look at this function, if we plug in a 0 into this function, 0, 0 plus 3, that'll give us a positive value. Now, if I plug in any positive numbers into x here, again, positive plus positive plus positive, I will get a positive value. Now, suppose I plugged in a negative value. Okay, so suppose I plugged in negative 5. Here, that will give me positive 25. The negative 5 here will give me negative 10 plus 3. we notice that no matter what, because we're squaring here and we're getting a positive value, that positive will always be big enough to overpower whatever negative value we're going to get here. So at the end, no value of x will make this negative. Even the negative numbers, when they go in here, the function will remain positive. So that tells me that this function is positive all the time. Okay, now I'm being asked, where is this less than 0 or negative? Well, we just saw that there are no areas where this function is negative or less than 0. So we say there is no solution. This is asking us for the opposite. This is asking us, where is this same function greater than or equal to 0? Positive or 0? Well, we saw here that this function is positive everywhere. So we say the solution is all real numbers. Okay, this is another interesting case here. When we factor this, we get x plus 6 less than or equal to 0. And again, I wanted to simplify this as well, so I switched this to simply less than 0. You notice you can write this as x plus 6 squared less than 0. So from here, I get x equals negative 6, and I only have one number to put on my number line. Okay. For a number greater than negative 6, let's say 0, when 0 goes into here, I'll get a positive value. Now, here, look at this. Let's use the same shortcut as we were before. Where did this negative 6 come from? It came from here. This parenthesis from where we got the negative 6 has an exponent of 2. It has an even exponent. That means at the negative 6, the sign does not alternate. It stays the same. Now, if that's a little hard to wrap our heads around, can we plug in a value from here, like negative 10, into this function? Of course we can. We get negative 10 plus 6 squared. That's still going to give us a positive value. Okay? So now, this is asking us, where is the function less than 0 or negative? Well, we see here that it's never less than 0 or negative. So again, the answer is no solution. With rational inequalities, these are where you have variables in the denominator. The only difference is, everything else is the same. The only difference is that we must also include the zeros of the denominator on our sign chart or number line. So let's do this first one. Okay, so we're going to solve this just like we did in section 2.2. And what we're going to do here is multiply both sides here by x plus 2. Okay, now here these will cancel. So I get 3x plus 4 greater than or equal to 0. Here, 3x greater than or equal to negative 4. X is negative 4/3. Okay, so the negative 4/3 definitely goes on this number line. But since this is a rational function, it has a variable in the denominator, as we said here, we also have to put in the zeros of the denominator. So let me just clean this a little bit. So I take the x plus 2, solve it for x, and that number also has to go on the number line. Now everything else is exactly the same. So I'm going to pick values and I'm going to plug them into my original function. So 3x plus 4 over x plus 2, and just make sure that it's being compared to 0, not another number here. Okay, so let's pick 0. When I put 0 into x here, in the numerator I get 4. In the denominator I get 2. Okay, so what I have there is a positive over a positive, and that gives me a positive. Okay, now, where did this negative 4/3 come from? It came from here. And you can see that if I were to write that in parentheses like that, it has an exponent of 1. That's an odd exponent. That means here, at the negative 4/3, the sign will alternate to minus. And now we go to the negative 2. Where did that come from? That came from here. That also has a quantity exponent, which is a 1, an odd number. So there too, it alternates. Again, could you have just plugged numbers in? Like can I have just said, let's plug in negative 3? Of course you could have. When you plug in negative 3 here, you get negative 9 plus 4. That's a negative number over another negative number, and that gives you positive. So either way works. This is just a little bit shorter. Okay, now what regions do we want here? Well, we want the regions that give us positive values. That's this and this. So again, this is an open-ended region. These are the numbers that are greater than negative 4/3. And these are all the numbers that are less than negative 2. So I say, for this region, x is less than or equal to negative 2, or x is greater than or equal to negative 4/3 for this one. Okay, lastly, here, we're going to multiply both sides by the LCD, x minus 2. And when the x minus 2's cancel from the numerator, I have x squared minus x minus 11 less than or equal to 3. And I'm going to distribute and get 3x minus 6. Move everything to the left side. We get x squared minus 4x minus 5 less than or equal to 0. When I factor, it's x minus 5, x plus 1. Okay. From here, I get that x equals 5 and negative 1. So those are definitely going to go on my number line, negative 1 and 5. Let's not forget that from the denominator, I also have to put in x equals 2. Okay, let's pick numbers again. Now, when we pick numbers, we have to plug them into this original equation, but one that is being compared to 0. So I have to bring the 3 over to the left side, and it looks like this: x squared minus x minus 11 over x minus 2. And now I'm going to subtract 3 to both sides. So I get minus 3 less than or equal to 0. So now let's plug in a 0. If I plug in a 0 here, I get 0 minus 0 minus 11 over 0 minus 2 minus 3. And again, students are allowed to plug this into their scientific calculators if we have to minimize the computation. Here I get negative 11 over negative 12, 2, so that's 11 over 2 minus 3. 11 over 2 is 5.5 minus 3. That gives me a positive value. So the 0 is here, I get a positive value. Okay, now let's see how we're going to do the other regions. Okay, the negative 1, where did this come from? Here, that has an odd exponent outside. The sign must alternate around the negative 1, so I have a negative here. Okay, now for the 2, where did the 2 come from? The 2 came from here. Again, that has a parenthesis to the power of 1, so the sign will alternate. Where did the 5 come from? The 5 came from here, exponent of 1, sign will alternate. Okay, I want the regions which are less than or equal to 0 or negative, so that's here and here. Okay, this region is open-ended on the left-hand side, so I say x is less than or equal to this number, negative 1, or here it's bound, so I put in the number to the right the number to the left, and that symbol always. So those are it. Okay, all right, so to sum up, suppose I have a 3 here, a 7 here. The region to the left is always going to have an x is less than. The region to the right is always going to have x is greater than. The region in the middle is always going to have this. Okay, and here to fill in our numbers, whatever number is here goes there, whatever number is here goes there, and for this one, it's the numbers on either side. Okay, so that's how it looks on the ends and in a middle portion. All right, and that is section 2.3. Thank you.